Welcome all. I think all of you can hear my voice. Welcome all. Can you hear me? Can you all hear me? Okay. Welcome to this session. Good evening all. Okay. In this session, we are going to discuss the reactivity of metals. In the previous session, we discussed more on the properties of metals and non-metals. In this session, we are going to know more on reactions. Okay, once again, welcome all. Let me know in the previous session we discussed on thermal conductivity and electrical conductivity, right? Which metal is considered to be highest electrical and thermal conducting metal? I'm waiting for your reply. Which metal will show highest electrical and thermal conductivity? We already discussed in the previous session yesterday. I'm not getting any reply from your side. Which metal will show highest electrical and thermal conductivity? Can you all hear me? Why I'm not getting answer? If you can hear me, I should get reply, right? Today we are going to complete this session. Can you all hear me? Then what is the answer? Which metal will show highest electrical conductivity and thermal conductivity? I'm not at all getting any reply. I don't know whether you all can hear me or not. Okay, I'll tell the answer. It is silver. Silver metal will show highest thermal conductivity and electrical conductivity. And the next rank goes to copper. As silver is most expensive, we'll use copper as a good conductor of electricity and also heat. Yeah, Arpita answered correctly. It is silver and copper. Both are correct answer, Arpita. Very good. And very good image. Nice. Yeah, Nandita, correct. Silver is the right answer. Because silver is very expensive, so we use copper in the electrical wires, and also we use copper coil for thermal conductivity. Because silver is very expensive, hence we use copper. Hope you all can differentiate the highest reactive metal and highest thermal conductive metal and highest electrical conductive metal, right? Can you all have variation between these three? Okay, already I got the answer, Kirti. It is silver. Silver is a metal which shows highest electrical conductivity and thermal conductivity. Okay, Kirti, clear? Silver is expensive, hence we use copper as the best electrical and thermal conductor. Is that clear, Kirti? Okay. Still, few more participants want to enter. I don't know what problem they have. Let me wait for a few more seconds. Okay, Kirti, fine. My next question is, which metals are called as alkali metals? Which metals are called as alkali metals? Okay, you have problem in my audio? You're not hearing clearly? No, Nandita. I posed question as alkali metals. Which are the alkali metals? Yesterday you all gave correct answer. Why today? No, Rekha. I am asking alkali metals. Give example for alkali metals. It is not gold. Wrong? Yes. Varalakshmi answered correctly. It is lithium, sodium and potassium. Very good, Varalakshmi. What is Neha answering illa? What is illa? Yes, Priyanka. Now I hope you can hear my audio. Yes. Now you all answering correctly. Very good. That is lithium, sodium and potassium are considered as alkali metals. And even yesterday we discussed some of the chemical properties of metals. That is, metals react with oxygen to form metal oxide. Now my question is 2x plus O2. 2x plus O2 gives rise to 2xO. Now, what is the metal in the name of X? And what is XO? What is the name of XO? And the third question is, what is the color of XO? I'll repeat the question. 2x plus O2 gives rise to 2xO. What is X here? And what is the name of XO? And what is the color of XO? I am waiting for your reply. Okay, color is black. Correct, Nandita? Okay, color is black. What is X? What is the name of XO? Okay, Nandita answered as copper. And the name of X is copper. Correct, Nandita? And the color is black color. Correct, Sandhya? Metal oxide, of course. Which is that metal oxide? Yeah, correct answer. I need XO. What is the name of XO? Yeah, Priyanka, copper is correct for X. And what about XO? Everyone answering as metal oxide. Name it. Which is that metal oxide? Yeah, Kirti, so late. Copper is right answer. I am asking what is the name of XO? Yes, Priyanka, correct. It is copper oxide. XO in the sense CuO. CuO means copper oxide. Very good answer. Okay, shall we move on for the next concept? Shall we move on to the next concept? Yes, copper oxide, black color, and the name of X is copper. All answers are correct. Very good responses. Very good. Okay. I'm going to share the screen, but don't know how far the voice is audible. Let me check after a small break. Okay, I'll start. Now I'm going to share the screen. Okay, we all know that in showing ductility, that is the metal drawn into thin wires. The metals showing the property malleability, that is the metal beaten into thin sheets. They are very good conductors of electricity. And this is, remember, this is not reactivity series. This is electrical conductivity and thermal conductivity series. Remember, this is very different from reactive series. Now here, silver is considered to be highest in showing electrical conductivity and thermal conductivity. And lead shows least thermal conductivity and electrical conductivity. I repeat, silver shows highest electrical conductivity and thermal conductivity. Lead shows least thermal conductivity and electrical conductivity. And they are good conductors of heat. All metals are good conductors of heat. These are the very important properties of metals and non-metals we discussed yesterday. That is, metals are showing lustrous, malleable, ductile, high melting point, high tensile strength, and sonorous. And this we discussed yesterday. The metals reacts with oxygen to form oxides. And there are two examples like aluminium oxide, zinc oxide. Reacts with acids and bases to form respective salt and water. I'll repeat. Aluminium oxide and zinc oxide. This is very, very important for your board exam. Aluminium oxide, zinc oxide reacts with both acids as well as bases to form respective salts and water. Hence, those oxides are called as amphoteric oxides. Today, we are going to study more how the metals react with water. Action of steam on a metal. Steam in the sense it is a form of water, the gaseous form of water. Now, the metal sample is took in a test tube and it is heated, and when the gas is released, it is collected in a beaker, and that beaker where inverted test tube is placed to the connector above it, so that when the hydrogen gas is released, we can observe air bubbles. Now, what has happened inside the test tube? The metal is reacted with steam. The metal is reacted with steam. When the metal is reacted with steam, obviously it releases hydrogen gas. So, in order to prove this, such simple experiment is conducted. So, this diagram is very essential for your board exam. Okay. Now, look at the equation. The metal reacts with water to form metal oxide, and even the metal reacts with water to form metal hydroxide. When metal reacts with water, it forms metal oxide with the release of hydrogen. When it results in the formation of metal hydroxide, there won't be any hydrogen gas release. Remember, when metal reacts with water, if it forms metal oxide, what is released? Hydrogen gas is released. If hydrogen gas is not released, then it results in metal hydroxides. Metal hydroxide. We'll go with the example. Potassium and sodium reacts violently with the cold water. Even with the just cold water, you just put a small piece of potassium or sodium. It reacts violently with the release of hydrogen. And that hydrogen immediately catches fire. It immediately catches fire. So, hence, as per reactivity series, potassium and sodium is considered to be highly reactive. Here, the statement goes like this. The potassium and sodium are highly reactive metals. Highly reactive metals. Okay. Later I am going to ask question on this. Potassium and sodium are considered to be highly reactive metals. Look at the equation. When potassium reacts with water, it results in the form of potassium hydroxide with hydrogen gas, because they are so reactive, so violent, hence they release hydrogen and that catches fire. And the next equation also, sodium reacts with water to form sodium hydroxide with the release of hydrogen, and that will catches the fire. Okay, look at another equation. Calcium is less violent and even calcium reacts with water to form calcium hydroxide, but the hydrogen not sufficient to catch fire. The heat evolved along with the hydrogen is not sufficient to catch fire. Why? The calcium is very less violent. Okay. Okay, Arpita got problem with the network, right, Arpita? And what about others? What about others? Even same problem? Have you all saw the screen? All of you heard my voice? Okay, Priyanka. All of you cleared with the equations, like how metal reacts with water and how the high reactive metals reacts with water and how the less reactive metal reacts with water. Is that clear? I'm waiting for your reply, because when I share the screen, let me know whether everything is cleared or not. Okay, fine. Only few girls having the problem. Only few. Please take a seat where there is a good network. If not, you will have network problem. Okay. Others, they are very good in receiving the concepts, right? Few are missing it. Don't miss these concepts. These are very, very important for your examinations. Okay. Again, I'll share the screen for... Okay, before sharing the screen, let me know the highest reactive metals. When it reacts with water, even with the cold water, what does it release? And what will happen if you place a candle near the released gas? I'll repeat. What happens when the high reactive metals react with cold water? What is released? And what happens if you place candle near the released gas? Hope question is understood. Very good, Priyanka. Excellent answer. Hydrogen gas will be released and it catches fire immediately when we bring the candle very close to the hydrogen gas, and we find pop-up sound. When hydrogen gas touches the fire, we find pop-up sound, blasting sound with a mild sound. Okay, very good answer. Now I'm going to share the screen. Let me continue with the equations. Now look at these two equations. That is iron and aluminium. They do not react with cold water, but they react with steam. Hence, side to the water, it was given the state gaseous form. When it is G is given, think that it is steam. Okay. Aluminium and iron reacts with steam to form metal oxides and the release of hydrogen. Metal oxide and the release of hydrogen. When aluminium reacts with steam, it forms aluminium oxide with the release of hydrogen gas. When iron reacts with steam, it forms iron oxide with the release of hydrogen gas. Ferric oxide with the release of hydrogen gas. But remember, lead, copper, silver, gold do not react with water. They do not react with water. I repeat, lead, copper, silver. Lead, copper, silver and gold do not react with water. Okay, this is about how the metals react with water along with the very important diagram. Look at reactivity series. This is called reactivity series. As per reactivity series, potassium is most reactive metal, and from the zinc it starts decreasing, but gold is considered to be least reactive. Not only gold, silver, platinum. Gold, silver, platinum is considered to be least reactive metals. Frankly speaking, platinum is considered to be least reactive metal. Even gold is also correct, silver is also correct, but platinum is the least reactive metal. Remember, this is reactivity series. Previously, we come to know that in the chart we come to know that silver is highest thermal and electrical conducting metal. Lead is least electrical and thermal conducting metal. Okay. Here potassium is most reactive metal. Platinum and gold is less reactive metal. Okay. Hope everybody cleared with this. Okay, very good answer. Yes, Revati, correct. That is, potassium and sodium are highly reactive metals. Hope the concept is cleared. Don't get confused with reactivity series, electrical conductivity series and thermal conductivity series. Any confusion with these three? Okay, all of you cleared? Okay, we'll move on. Okay. And next concept, we are going to study how the metals and non-metals react. Till now, we discussed on how metals reacts with oxygen, how metals reacts with water. And those two concepts are so important for board exam. And now, we are going to discuss on how the metals and non-metals react. We all know that the metals will have very less electrons in outermost orbit. Now, I'll give an example. Sodium, outermost orbit will have 1 electron, right? Okay. And the next one is nonmetals. Nonmetals will have high electrons in outermost orbit. High electrons in outermost orbit. Example, chlorine. How many electrons will be there in outermost orbit? It is 7. 7 is high and sodium has got only 1 electron. So, Okay. Sodium loses one electron. Sodium loses one electron to attain octet structure. Chlorine gains one electron to attain octet structure. Okay. Now this I am going to show with the image. Now look at the image carefully. Shall I share the screen? If any confusion here, let me clarify. Okay. Okay, we'll move on. Okay, Kirti, any doubt? You have any doubt? Which concept should be repeated? I'll repeat the concept, Kirti, where you need clarification. Even Revati has got problem. Why? Why Revati? What is the problem? Which should be repeated? Yeah, Kavya, welcome. Why so late? Today we want to complete this session at any cost. Okay. Now, what should be clarified? Revati and Kirti, what doubt you have? Okay, rest of the girls, they were eagerly waiting for next concept. Now let me know, Kirti and Revati, do you have any confusion here? Want me repeat? Okay, Kirti got doubt on reactivity series. Okay, reaction in the sense when the metal reacts with oxygen, when the metal reacts with water, how it reacts, violently or non-violently. This is the reactivity. When sodium is just opened and just kept open without any external force, it reacts with the oxygen because sodium and potassium are considered to be highly reactive. Okay, gold, silver, platinum, these are noble metals. They exist in nature form. Nature form in the sense they don't combine with any other non-metals or any other compound state. They exist as a pure state. Why they exist as a pure state? Because they are least reactive. Platinum, gold, silver is considered to be least reactive because they are pure metals. Okay? So, highest is potassium and sodium and least is platinum, gold and silver. Okay, Kirti? Kirti, is that cleared? I'm waiting for Kirti. Is that cleared? Okay, Kirti is not replying. Still she got doubt. Okay, let me check Kirti later on. Okay, let me continue the session. Now I am going to share the screen. This is about reactivity series. Potassium, sodium is most reactive. Platinum, gold, silver are least reactive. Now, one more concept. Before entering into metals and non-metals, now how the metals react with acids. The metals like magnesium, aluminium, zinc and iron reacts with dilute hydrochloric acid to form respective salts, and very important, hydrogen gas is released. Remember, when the metals reacts with dilute hydrochloric acid, it releases hydrogen gas with the salt formation. But what about when it reacts with nitric acid? When the metals reacts with nitric acid, hydrogen gas is not released. Instead, water is formed. Why water is formed? Nitric acid is oxidizing agent. It supplies the oxygen. Hydrogen combines with the oxygen supplied by the nitric acid. Hence, water is formed. No hydrogen gas is released. Remember, this is very important for your board exam. And these equations are not given in your book. It's not given in your book. Okay. It's better to have a screenshot of this. It will be useful. Now, magnesium, aluminium, zinc and iron combines with dilute hydrochloric acid to form respective salts with the release of hydrogen. When these metals reacts with nitric acid, along with the respective salts, the water is formed. Why the water is formed? Nitric acid is oxidizing agent. It supplies oxygen, and that oxygen combines with the hydrogen to form water. Okay, all of you cleared? How the metals reacts with acids? Which gas does it releases? Very good, Revati. Very nice. Okay, because it was not given in your book. Okay, now my question is, when metals reacts with dilute acid, it results in the formation of what kind of gas? What kind of gas is formed? I'm waiting for your reply. Yes, it is salt and hydrogen. Respective salt and hydrogen is formed. Okay. What happens when metals reacts with nitric acid? What is formed? Yes, Neha. Correct answer, Neha. Good. Venkat Raju. Kirti, what is that hydrogen form of salt? Hydrogen plus salt. Yes, all of you answering correctly. Very good. Very good answers. Good, Priyanka. Who is under Gaurappa? She is answering very good from the beginning. Good, Shreya. I didn't get response. What happens when metals reacts with nitric acid? Very good. Venkat Raju. Who is under Venkat Raju? I forgotten the name. Okay, Varsha. Good, Varsha. Yes, Neha, correct. Very good responses. Good. Who is under Venkat Raju? Okay, Vidya. Yes. Previously you told. I forgotten. Good, Vidya. Okay, no problem. No problem, Priyanka. Okay, if you answered very good. Okay, now I'll continue the session. I'll share the screen. Okay, this is an experiment how the metals react with other metals. How the metals react with other metals. Now, when you see the diagram in a test tube, there is copper sulfate and iron nail is dipped in copper sulfate. Now, iron and copper, both are the metals. Which is more reactive? Iron is more reactive than the copper. So, iron replaces copper. Iron replaces copper. Iron replaces copper, and finally the solution, the bluish solution, will become iron sulfate. Later on it will become iron sulfate, brownish iron sulfate. Why it is so? When metals react with another metal, the high reactive metal replaces less reactive metal. Iron is high reactive, hence it replaces copper. Iron replaces copper. Suppose, think of in iron sulfate solution, we have took iron sulfate solution in a test tube. Now, I am going to dip copper wire into iron sulfate. What is the result? What is the product? What is the product? And what is the name given for this reaction? You all studied previously. You all know this. What is the name given for this type of reaction? Okay, I'm waiting for your reply. When iron placed in copper sulfate, iron replaces copper because iron is highly reactive. What happens if we dip copper wire in iron sulfate solution? And what is the name given for such reactions? Very good, Priyanka. Excellent answer. It is displacement reaction. So, the highly reactive metal displaces the less reactive metal. Very good answer. Priyanka, keep it up. Now, one more question. What happens if copper dipped in iron sulfate? What happens? This is very important. Such questions will be asked in your board exam. Yes, Arpita, very good answer. It is displacement reaction. Very good. Yes, Vidya, correct. Varsha, correct answer. Yes, Revati, Sneha. Correct answers. Very good. Still, I didn't get for another question. I didn't get answer for another one. Yes, Kirti, Kavya, very good answers. No, Revati, it's wrong. No. When we dip iron in copper sulfate, iron displaces copper and hence iron sulfate is formed. But when you dip copper in iron sulfate, copper is less reactive. Iron is more reactive. Copper cannot displace highly reactive metal. So, no change takes place. No changes because copper is less reactive. It cannot displace iron. Why? Iron is more reactive. Copper is less reactive. No displacement. No displacement reaction takes place. Cleared, all of you? Want me repeat? Cleared? No, Kavya. Wrong answer, Kavya. Just now I gave complete information. Let me give. Okay, let me see correct answer from your side. Let me see correct answer from your side. Okay, it is cleared. But what is the answer? When copper dipped in? Yes, Priyanka, it is correct. No changes takes place. No change takes place. Correct, Revati, it's correct. Good answering. Good answering. Okay. Hope everybody cleared with the concept. If the metal is highly reactive, displacement takes place. If it is less reactive, no displacement reaction takes place. No change. No displacement reaction. Yes, Kirti. Correct answer. No displacement takes place. Yes, copper is less reactive. No change takes place. Okay, correct answers. Okay, I'll continue. Okay, fine. Now, we are going to study more on how the metals reacts with non-metals. Now, look at the electronic configuration of sodium 281. One electron is present in outermost orbit. So, always the metals have less electrons in outermost orbit. When you look at chlorine 287, 7 electrons are found in outermost orbit. Now, sodium has got 1 electron, so 1 dot is made near sodium. Chlorine has got 7 electrons in outermost orbit, so 7 dots are made round the chlorine atom. Okay, now count the number. How many dots are there around the chlorine? Count. It is 7. How many dots are there near the sodium? It is 1 dot. these dots indicates electrons count at outermost orbit. Okay, now always highest number will be stronger than least number. Sodium has got only one electron, so sodium cannot drag 7 electrons. Highly impossible. So chlorine has got 7 electrons outermost orbit, so it easily gets 1 electron from the sodium. Sodium will donate 1 electron. Chlorine will receive 1 electron. Okay. Now 2,8 is Na plus. 2,8 is Na plus. Why 2,8 is Na plus? Plus in the sense they donated 1 electron. Cl minus is 288. 288 electronic configuration. Why 7 has become 8? Chlorine ion received 1 electron. Now sodium ion is 2,8 electronic configuration. Chlorine ion is 2,8,8. How it has done? By donating electron and by receiving electron. When electrons are donated and received, then those atoms are called as ions. Those atoms are called ions, and hence between sodium and chloride there will be ionic bond. Formation of ionic bond. The other name for ionic bond is electrovalent bond. Electrovalent bond or ionic bond, both are one and the same. Now between sodium and chloride ions are formed and it results in the formation of ionic bond, and thus ionic compound is formed. Sodium chloride is ionic compound. And what are the important properties of ionic compounds? They have high melting point and high boiling point. The physical state is they are very hard and they have very strong force of attraction between positive and negative ions, and generally they are brittle and usually break into pieces when pressure is applied. Now take the crystal salt. You just take a small stone, hit on crystal salt. It becomes powder salt because they are brittle in nature. Easily they can break into pieces. It is very important feature of ionic compound. They have high boiling point and melting point. When they are in solid state, they do not conduct electricity. Why? When they are in solid state, they do not conduct electricity because they are in compound state. When they conduct electricity, when they change into ions. When they change into ions. When they are going to change into ions? When it is mixed in water. When sodium chloride is dissolved in water, sodium and chlorine converts into ions and easily it conducts electricity. So remember, ionic compounds do not conduct electricity in solid state. Only when it is mixed in water, it releases ions, and ions are responsible to conduct electricity. Okay, and one more important point is solubility. Ionic compounds or electrovalent compounds are generally soluble in water and insoluble in kerosene, petrol. I'll repeat. Ionic compounds are soluble in water but insoluble in kerosene and petrol. This about the reaction between metals and non-metals, how the ionic compounds are formed or electrovalent compounds are formed, and what are its general properties. So this is about the reactivity of metals with oxygen, with water, with other metals and with non-metals. Till now we discussed on these concepts. Now we are going to study on occurrence of metals. Okay, all of you cleared with ionic compounds? The reaction of metals and non-metals? Yeah, Tanushree, welcome Tanushree, so late. Very good, very good. This concept is so simple because we already discussing these concepts. How the positive charged ions are formed, how negative ions are formed from periodic table. We were discussing on that. Now the compound formed between metal and non-metal is ionic compound. Remember, this is one sequence to identify which is an ionic compound, which is an covalent compound. Hydrogen molecule, oxygen molecule, methane, ethane, propane and all hydrocarbons are covalent compounds. Between magnesium chloride, sodium chloride, all these are ionic compounds. Okay, and you all cleared with the properties of ionic compounds? All of you cleared? Okay, very good. All of you cleared? Now, we are going to discuss on occurrence of metals. In this occurrence of metals, we are going to know more on how to extract metals, which were the different methods to be followed while extracting the metals. Okay. Now, how do metals occur? Now, the elements are compounds which occur naturally in the earth crust are known as minerals. The minerals along with impurities are called ores. The metals along with impurities are called ores. The impurities present in the ore is called gangue or gangue waste. Okay. These three concepts cleared? Should I want to repeat? Want me repeat? What are minerals? Elements or compounds which occur naturally are called minerals. Elements or compounds occurring naturally are called minerals. Minerals with some impurities are called ores. The impurities present in the ore is called gangue. The impurities present in the ore is called gangue. Okay, all of you cleared? Okay, let me know how far you are cleared. What are minerals? I'll give time because if you cleared with this concept, it's easy to move on. Okay, what are minerals? It takes time, but still I need the answer. I'm waiting for your reply. I'm waiting for your reply. What is mineral? I'm waiting for your reply. I'm not getting any answer. What is mineral? Yes, Priyanka. Very good answer. Very good answer. Yes, elements or compounds which occur naturally are called minerals. Very good. Okay, correct answer. And what are ores? What are ores? Yes, good answer. Minerals along with the ores are called minerals along with the impurities are called ores. Very good. And even for what are minerals? Very good answers from Kirti, Varsha, Varalakshmi, Priyanka. What are ores? Very good answer. Yeah, Shreya, very good answer. Okay. Now, the impurities present in the ores are called as the impurities present in the ores are called as yes, Priyanka, very good answer. It is Ganji. Ganji athva Gangu. Both are correct. Yes, Vidya, correct answer. Yes, Revati, correct concept is correct. But you're not answering my question. Concept is good. Metal is extracted from ore. Very good answer. Still, I didn't went for that concept. Yes, Ganji. Ganji is right answer. The impurities present in ore is called as Ganji. Okay, cleared, all of you. Okay, next concept. Now I'm going to share the screen. Okay, the other important properties of ionic compounds are ionic compounds dissolve in water, they don't dissolve in kerosene and petrol. Ions easily get separated when it is dissolved in water. Solutions will conduct electricity. And ionic compounds like sodium hydrogen carbonate, bicarbonate, baking soda, all these are the example for ionic compounds. When ionic compounds are heated, it releases carbon dioxide. Okay, this is about the properties of ionic compounds. And this is how we can extract the metals. Now extraction of metals. Now how we can extract the metals from the ores? We can extract the metals from the ores by separating the gangue. When we separate the gangue from the ores, we'll get the metals. And the process of refining the metals, removing the impurities is called enrichment of ores. What is enrichment of ores? Separating of gangue from the ores. Separation of gangue from the ores is called enrichment of ores. Purification of metals or refining of the metals, removal of the gangue, all are one and the same. And this process is called as extraction of metals. I hope cleared. Enrichment of ores is very simple. Removal of gangue from the ores, refining of the metals, separation of impurities from the ores, and this process is known as enrichment of ores. Now, how enrichment of ores are done? It is based on the type of the metals. Now, look at the table. The first column, the metals of high reactivity. The metals of high reactivity, the metals are separated by electrolysis. Why? They are highly reactive. Hence, electrolysis is the only method to get the pure metal. Look at the second one. The metals of medium reactivity. The metals of medium reactivity, it is carbonate ores or sulfide ores. The metals of medium reactivity are two types. That is carbonate ores or sulfide ores. Now, how the carbonate ores are purified? How the carbonate ore is enriched? It is by calcination. Remember, carbonate C letter, calcination C letter. Carbonate ores are refined by calcination. Now, sulfide ores are refined by roasting. Okay, cleared? Calcination and roasting. These are the two methods applied on metals of medium reactivity. Metals of medium reactivity. And the last one is metals of low reactivity. The metals of low reactivity are sulfide ores. Usually sulfide ores are very less reactive, and even some sulfide ores are medium reactive. The less reactive ores are separated by roasting, by simple method called roasting. So all of you clear with this concept? Now all of you clear with this concept? Concentration of ore means separation of gangue from the ores. Enrichment of ore, concentration of ore, right? So how it is done? Based on the reactivity of the metals. For highly reactive metal, electrolysis is a method. For medium, calcination and roasting. For less reactive, it is roasting. Roasting is done. All of you clear with this? Okay, if it is clear, we'll move on. Let me complete this at any cost today. Is that boring? Is that boring? Shall we continue? Shall we continue? Okay, we'll continue. Okay, fine. Okay, extraction of metals based on high reactivity, medium reactivity and low reactivity. For high reactivity it is electrolysis. For medium reactivity it is calcination and roasting. And finally reduced by carbon. Finally reduced by carbon. And low reactivity it is roasting. Roasting is the method. Now we look after one by one. How metals are extracted of low reactive metals. Cinnabar HGS. HGS, that is mercuric sulfide. Cinnabar HGS is an ore of mercury. This will be asked for 1 mark question. What is cinnabar? HGS. It is ore of mercury. If it is asked for 1 mark, it is ore of mercury. This is very important for 1 mark. And how mercury is separated? First thing is, it is an sulfide ore, and the method we have to apply is roasting. What is roasting? The sulfide ores are heated with excess of oxygen to convert it into oxides, metal oxides. I'll repeat. The sulfide ores, when it is heated in excess of oxygen, it results in the formation of mercuric oxide or metal oxides, and that metal oxides are reduced by carbon to convert it into mercury. Okay. Now look at the equation. Cinnabar plus oxygen, mercuric oxide, along with release of sulfur dioxide. Next, mercuric oxide, and that finally on heating mercury is separated. Now look at one more example. Copper sulfide, Cu2S, copper sulfide. When it is roasted in excess of oxygen, roasting in excess of oxygen, it forms metal oxide, that is copper oxide with sulfur dioxide. And copper oxide along with again copper sulfide with again copper sulfide, when it is heated, the copper is separated. Copper is separated. So these are the 2 examples of extracting the metals of low reactivity, that is cinnabar and copper sulfide. Copper sulfide otherwise called chalcocite. Chalcocite. Copper sulfide otherwise called chalcocite. Okay, all of you cleared with metals of low reactivity extraction, that is cinnabar and copper sulfide. So want to repeat, or shall we move on to middle active metals? Okay, if it is cleared, we'll move on, because another 2 concepts under metal extraction, and finally only 1 concept will be left over. Finally 3 concepts. Okay, shall we complete? Okay, I'll continue. Extractions of, okay, this is same thing, that is cinnabar and copper sulfide. Okay, same what we discussed just now, same image, same reactions. Now we'll go for extracting medium reactive metals or middle reactive metals. The middle reactive metals can be extracted by simple methods called roasting and calcination. So sulfide ores are converted into oxides by heating in excess of oxygen, is known as roasting, right? And carbonate ores are heated in limited amount of air, is known as calcination. The carbonate ores heating in limited air with less amount of oxygen to form oxides is known as calcination. So the question may ask here, what is difference between roasting and calcination? What is roasting? What is calcination? Sulfide ores are heated in excess of oxygen to convert it as oxide. Metal oxide is known as roasting. The carbonate ores are heated in limited amount of oxygen, less amount of oxygen, to convert it into metal oxides is called calcination. This will be asked in your board exam. What is difference between roasting and calcination? Okay, let me go with an example. When zinc sulfide heat okay. So the example is when zinc sulfide, this is an sulfide ore, okay. When zinc sulfide, when it is roasted in excess of oxygen, it gives rise to zinc oxide, okay. And the other one, zinc carbonate, this is carbonate ore. Carbonate ore in limited amount of oxygen, there is no oxygen here, limited, very less amount of oxygen. Again, it is formed zinc oxide. In both the cases, in zinc sulfide and zinc carbonate, zinc oxide is formed, but the difference is sulfide is treated with oxygen, that is called roasting. Zinc carbonate, there is no oxygen, limited oxygen, then too it forms zinc oxide. One more difference is sulfide ores gives rise to sulfur dioxide, release of sulfur dioxide. Carbonate ores gives rise to release of carbon dioxide. Okay. All of you cleared? Roasting and calcination. This is very important. Roasting and calcination differences along with one equation. Okay, cleared? We'll move on. Extraction of metals which are highly reactive. And which are highly reactive? sodium, potassium, magnesium, right? And along with that, calcium, aluminum, all these metals are extracted by electrolysis. And how we can conduct electrolysis? Extracting metals to be dipped in metal salt solution where anode and cathode are connected to the battery in term electricity, and in the metal salt solution it will convert into ions, and ions moves towards to cathode and anode, and thus electrolysis will be done. Okay, what is the example given here? How the sodium can be extracted? Look at here, sodium chloride. Sodium will move towards the cathode. Hence, cathode electrode always made by pure. Always the cathode plate will be pure because we are extracting the metals. Metals will carry positive charge, and positive charge always moves towards the cathode. Why towards the cathode? Cathode carries minus, negatively charged. Positive charges always moves towards the negative charge cathode. Any confusions here? I'll repeat. Highly reactive metals are extracted by electrolysis. Electrolysis where metal salt solution is taken. In that, anode and cathode are connected to the battery. Cathode is negatively charged, anode is positively charged. And the metal to be extracted always moves towards the cathode, and always cathode is made with the pure plate. Cathode is made with pure plate, and hence finally all metal move towards cathode, and we just remove the cathode, we'll get pure metal without any impurities. And where the impurities will go? It will be settled down, and settled impurities are called anode mud. Settled impurities are called anode mud. This is about how to extract highly reactive metals. We'll know clearly with one more example, copper extraction by electrolysis, electrolytic refining. Okay, this diagram is so important, very important for your examination, board examination. Now, what is a metal salt here? Copper sulfate is taken in a beaker. Cathode is a pure copper plate, And what is anode? Now, what is to be separated? Complete ore is filled in anode. Complete ore is filled as an anode. Anode has got both impurities and pure metal. Okay, I'll repeat. In order to extract copper, we take copper sulfate solution as an electrolyte which can conduct electricity. Cathode is made up of pure copper because we are extracting copper. If it is gold, then it is gold. Okay. Now what is anode? Now ore, impure ore is made as anode. Now when battery is connected, electricity is passed. Now anode has got metal, that is copper metal, Cu plus, Cu2 plus, right? And Cu2 plus starts moving towards the cathode. Cu2 plus moves towards the cathode, and hence the pure copper is settled on cathode, by separating the cathode, we'll get pure copper without any impurities. Where will be impurities? Just below the anode, you just look. The impurities are settled as anode mud. Why? The mud are settled down. The copper moves towards the cathode and we'll get pure copper by electrolytic refining. This is very important for your board exam. The last concept is corrosion. What is corrosion? Many times we see that metals attacks by chemicals, salts, water, acids, moisture, and thus they convert into oxide or hydroxides, and thus corrosion occurs. As a result of corrosion, the metal will be completely eaten up, damaged. So, it's very important to prevent corrosion. I'll give example. What are corrosions? Silver articles. Silver articles usually converts to black color. Why? The silver articles combines with sulfur present in the air and it forms silver sulfide. I'll repeat. Silver articles combines with sulfur to form silver sulfide, which is a black color coat, and that is called corrosion. Copper reacts with carbon dioxide to form green coat, and that green coat is nothing but copper carbonate. This is also called corrosion. Iron, when it is exposed to air, it forms brown or reddish flake substance called rusting. Okay, this is also called corrosion. And if we are not protected this corrosion, complete metals will be eaten up. Now, how to prevent corrosion? By painting, by coating, by alloying, by oiling, by greasing, by galvanizing, by chrome plating, anodizing, and making alloys. These are the best methods to prevent corrosion. Okay, so the last concept, one thing I left is, when I don't have the image of that, I'll just explain. Okay, when the metal oxide, that is iron oxide, allowed to react with aluminium, then it results in the formation of the molten state of iron and aluminium oxide. I'll repeat. When iron oxide is heated with aluminium, obviously what happens? Displacement, that is iron gets separates. Iron and aluminium oxide is formed, and this combination molten state is called thermit reaction. This reaction is called thermit reaction. And why this is very important? The combination of aluminium oxide and iron is used to join railway tracks. Railway tracks. And these are non-corrosive. These are non-corrosive. Hence, thermit process is done in order to prevent corrosion of the railway tracks. Okay. Hope everyone understood the concept. It was heavy today, but we completed this session. Okay. Now today you all have very good work. All of you go with the equations. What is thermit reaction? what is the equation, and how the metal extraction of low reactive, medium reactive, and high reactive, what are the equations, what are ionic compounds, what are the properties, everything you should go through that. Okay. Okay, all of you, now the question is, now I'm going to pose a question. Let me know how far you all understood. What are the important properties of ionic compounds? Important properties of ionic compounds. Good answer, Priyanka, Revati. Good. Let me see few more points. Good, Priyanka. Varsha, correct? Good, Arpita. Revati, that is not the right statement. The statement is like that. The ionic compounds in water, they will conduct electricity. Okay, Revati? Okay. Now, just now I explained at the last what is thermit reaction. Can you able to answer what is thermit reaction? Good, Arpita, Bhargavi, and under name Mahesh, good answers. And what about thermit reaction? What is thermit reaction? Good, Priyanka, but it will be in a molten state, and that will be used for joining the railway tracks. And why it is done in such manner? In order to avoid corrosion. So this molten is applied, then it will become hardened, and it will join, and it will be very resistant to the corrosion, and hence thermit reaction is done. Okay. Okay, my next question is, what is roasting? What is roasting? What is roasting? What is roasting? Good, Bhargavi. Good answer for Tanmit reaction. Good, Priyanka. Very good answer. Good answer, Tejashwini. And even Varalakshmi, good answer. Okay, Revati gave advantage. Correct advantage, Revati. Yeah, Revati gave before only reaction also. Good. Good, Varsha. Good answer. Good, Kirti, Vidya. Good answers. Good, Arpita, Bhargavi. Good answers. Okay, my next question is what is calcination? What is calcination? Yeah, Tejashwini, very excellent answer. Good. Good answer, Tejashwini. Yeah, correct, Priyanka. Varalakshmi, good answer. Good answer, Revati. Good. Okay, my last question. Each one of you can explain any one reaction of metal with either oxygen, water, with other metal, or with other non-metal, your wish. Each one should explain one reaction. Metal with other metal, metal with non-metal, metal with oxygen, metal with water. Any one from each. Okay, this will be the last question. Please try to answer. Why no one is answering? Feeling difficult? Forgotten the concepts? Look at your answer, Priyanka. It is not potassium hydroxide. It is potassium. When it reacts with water, it forms potassium hydroxide. Okay, you done mistake. You just correct it. Look at your answer. And what about others? No one answered other than Priyanka. What is that, Bhargavi? Potassium hydroxide reacts with winter. Huh? Completely wrong. Now it's correct, Priyanka. Very good answer. Okay, all of you listen. The last question. You can answer for this because you all feeling very difficult in selecting which reaction, right? I hope that is the difficult one. Okay, final question. What are amphoteric oxides? What are amphoteric oxides? Okay, Kirti answered. Very good, Kirti. Good answer. Good. Okay, now you can answer for the question. What are amphoteric oxides? Good, Kirti. Correct answer. Yeah, Priyanka, you got confused. Those are alkali metals. Okay, those are alkali metals. I'm asking amphoteric oxides. What are amphoteric oxides? This is very important for your board exam. Okay, don't get confused here. No, Varsha, why? If someone answers, same thing will be repeated even though it is wrong. Varsha, you repeated Priyanka answer, right? That's not correct. Yes, Revati answered correctly. Very good, Revati. And you didn't give example. Okay. Good, Revati. Good answer, Priyanka. Very good. Good presentation of your answer. Excellent presentation. Okay. Today, let me wind up the session. Okay. Thank you all for the visiting and for your excellent answering. Thank you. Zero వచ్చిందా?